Okay, so we have 3 groups, and those are the scores. First group, 3 people, 4, 6, 8. Second group, 2 people, 1 and 5. And the third group, 9, 10, 5. The mean, 6, 3, and 8. By the looks of it, do you think that one group is doing better than the other? Which one? Number 3. But we can't stop there, because just because one number is bigger doesn't mean statistically it's significant. So we need a test, and we do it because things are random. We're dealing with random observations. What is the key difference between this example and the one that we did last time, French cuisine? Do we remember that example? The Zagat rating. So we had a lot of observations, at least I believe it was 10 in each. They had equal number of observations. Here we had an equal number of observations, but one of the conditions is that the standard deviations must be almost identical. We can't expect them to be exactly equal in practice, nearly equal. There is the ANOVA summary, but what I'm going to do is I'm going to show you how to find this using the calculator. So we have 3 lists. Let's put the data for list 1, excuse me, group 1 in list 1. So start number 1. Oh, somewhere start number 4. Going to get rid of all the data. So group 1, we have 4, 6, and 8. Group 2, 1 and 5. Group 3, 9, 10, and 5. Good. So our null the average score of the first group, which is the group which would be the group that never studied a foreign language but had good English skills. Group 2 never studied foreign language before and had poor English skills. The last one studied at least one foreign language. So the note is that the averages are statistically the same. The alternative, at least one of them is different. Yes. Here, Can ANOVA tell you exactly which one is different? No. It can tell you that at least one of them is different, but in order to determine which ones are different, we need something called a post-hoc test. I showed you last time using SPSS. So press start, over to tests, scroll down. To ANOVA. Option H. Good. Second 1, comma, second 2, comma, second 3. Enter. And that's what we have. So if you recall from regression, we had an ANOVA summary there, SS regression, SS residual. Here, we simply have group or treatment or population, one and the same. So you can call it as group, you can call it as treatment, you can call it as population, error and total. What was the first column? Not previous ANOVA, as always. Degrees of freedom. The next.
Sum of squares.
Next.
MS.
Mean squared.
F.
And lastly,
P.
standard layout. So the calculator actually gives you those values. F is 2.5. The p-value is 0.17677. I'll call it 68. For the factor part, now what is the factor? What the calculator calls as factor is the same as degrees of freedom. Excuse me, it's the same as group or treatment or population. So for the factor, the degrees of freedom is 2. Sum of squares, 30. We know if we take the sum of squares, divide by the degrees of freedom, we will get the mean squared. So 15. The error part, degrees of freedom is 5. Sum of squares, 30. Divide sum of squares for error by 5, you get mean squared. 6. What is the standard F statistic? F statistic is simply the ratio of MS factor treatment group divided by the error, MSE. So 15 over 6 would be 2.5. The total is simply add stuff. So 7 and 16. You can't add the mean squares. You can add the sum of squares at the F, but that's it. Good. Now you will see at the bottom there it says SXP. SXP stands for pooled standard deviation. Or simply the variance, pooled variance. If the standard deviation is 2.449, how do you find the variance? What should you do?
Or 998.
Square that, you will get 5.998.
Yeah.
Which is approximately 6. Do we agree? Yes. So the pooled variance is the same as MSE. One and the same. Good. MSE, pooled variance, one and the same. So, should we reject the no and conclude that at least one of the groups is different? In other words, studying a foreign language or knowing a foreign language, does it benefit you in learning French? From the original data, it seems like group 3 had a greater average score. By all means, it seems like if you studied at least one other foreign language, you can learn French easily, or it's the best way to learn French. But statistically, is that true? Is one group better than the others? We can answer that if we rejected no. If we rejected the no, at least one of the groups is different. We have an average that will be different. So my question to you is, should we reject the no? Why, Chris?
Because group 2 has 3.
Root 2 is 3. What?
Under group 2's mean, it's 3. Or is it just because one of them's different? The mean is different. from one of the groups.
Definition the purpose of statistics there, Christian. Do you hear that loud sound? That's my heart breaking. So just because the averages are different doesn't mean one group is better than the other. We did this entire procedure to determine if one group is different than the other. So the no means the average scores are the same for all 3 groups, no difference at all. Alternative, at least one of them is different from the others. That said, we have the ANOVA summary, we have a test statistic, we have a p-value. Based on what you see, should we reject the no?
No,
Huh?
No.
No, why not?
because the p-value is greater than 0.05.
Because the p-value is greater than 0.05. P-value is 17.68%, alpha is 5%, so we do not reject no. So there is sufficient evidence to conclude that there is no difference among the 3 groups. The area in the right tail is 0.05. We need the 2 degrees of freedom. The first degrees of freedom here is 2. The second d of 2 is 5. So second column, 5. What the hell is that? Okay. 5.79.
Yeah.
The French are still here. They're everywhere. So 5.79. Should we reject the null? The test statistic is 2.5. Critical value is 5.79. 2.5 is right over there. So the conclusion, once again, is to not reject the null.